Our final topic for consideration today, section 1.6, is about the properties of exponents. So it helps to remember, what do we mean when we say exponents? We call, if we say 3 squared or 3 to the 2, it means 3 times 3. Similarly, if I say 2 to the 4, it means 2 times 2 times 2 times 2. So 4 of them. Exponentiation is repeated multiplication. Brings us to our third definition of the course. This notation here, we say x to the a means repeated multiplication. We multiply x times x times x a many times. The number x is called the base, the number a the exponent. The quantity x to the a is read x to the a or x to the 8th power. A lot of this course will be dealing with exponents, so we want to make sure that we are solid on how to manipulate, simplify, and work with exponents. So when working with exponents, we have a whole bunch of exponent properties and rules that allow us to simplify and combine things very nicely, the first of which is called the product rule. So recall the product rule says if I have some real number x and some numbers a and b, right now we're just going to look at integers. Later we can expand this to include other types of numbers, but right now we'll just deal with integers. Integers meaning positive and negative whole numbers, including 0. So if I have x to the a and I'm multiplying that by x to the b, I can simplify this. I can combine these exponents by adding them. That is the same as x to the a plus b. That is our product rule. Let's look at why this works. Here's our example. If I'm going to take 4 squared times 4 cubed, so 4 to the 2 times 4 to the 3. I'm just going to use the definition from the previous page and expand this. What is 4 squared? Well, that is 4 times 4, right? Multiplying 4 by itself. Just the one time, actually. There are 2 of them. Well, I'm taking that and I am multiplying that by 4 cubed. What's 4 cubed? Well, 4 cubed is 4 times 4 times 4. Oh, what's all that mess? 1, 2, 3, 4. I have 5. Multiplying 4 by itself 5 times. Definition tells me that is 4 to the 5th power. How else could I have gotten this? Take the 2, add the 3. 4 to the 2 plus 3. You may prefer to use the definition and expand everything out, but after a while it gets quite tedious. So if I'm given a variable x and say let's find x to the 6 times x to the 5th, I can simply apply my product rule. I have the same base. I will add the exponents. So the 6 plus 5, that simplifies as x to the 11th power. We want to be careful though. Don't make the mistake of assuming that this works in general for any old numbers, right? If I have x to the a times y to the b, I can't really simplify that by adding the exponents. They have to have the same base, Otherwise, I cannot do that. So be careful there. Do not let yourself be fooled. Look at example 6. Let's multiply and simplify the following. Notice I have numbers and letters this time, numbers and variables. I can rewrite this without the parentheses. Parentheses is just a fancy way of saying I'm multiplying. So that's negative 4 times m to the 7th times 6 times m squared. I have got just numbers here, so actually I can rearrange this. This is the same as negative 4 times 6 times m to the 7 times m squared. Let's see, negative 4 times 6, how about 24, but it's negative. And then in this case, I can use my exponent properties and say that's the same as m to the 7 plus 2 negative 24, 24, m to the ninth. Why could we do that? Why could I just shuffle things around? Remember from back in the day, our old friend, the commutative law. The commutative law says for real numbers, if I have a and b, this is true for addition. If I take a plus b, that's going to be the same thing as b plus a. It's also true for multiplication. If I take a times b, it's the same as b times a. So if all I have here is a bunch of multiplication, and that is what I have, just a bunch of multiplication, then I can shuffle these things around to my heart's content without fear of altering the result. So we can use the commutative law in this next example to help us out a little bit here because we've got multiple variables. But notice it's still all just multiplication. I don't have any addition or subtraction happening here. It's just multiplication. So I can rearrange this. I can group the letters, group the numbers. Should I pick a color here? How about I group all of the letters here, or all of the numbers here, excuse me. So 2 times 4, those are my numbers. I have x's, so I have x to the fifth and x, just x. Now, note, if no exponent is written, I can write 1. X to the first power is the same thing as x. So if there is no exponent, I take that exponent to be a 1. I can group my y's. I have a y squared and a y squared. And I can group my z's. I have a z to the 9 and a z to the 3. Z to the 9, z to the 3. Okay, now I can either just straight up carry out the multiplication right here, 2 times 4. Pretty sure that's 8. And now I apply my product rule. This is x to the 5th times x to the 1st. Well, that's x to the 5 plus 1. Y squared times y squared is the same thing as y to the 2 plus 2. And z to the 9, z to the 3. Well, there's that z to the 9 plus 3. Final simplified form. How about 8 x to the 6, y to the 4, and z to the 12. Whee! Lovely.